All right, today I'm going to show you how to write formulas and name ternary ionic compounds with group A metals and the transition metals as well. So this will take a little bit longer to do that. And first thing I want to point out is when it says ternary ionic compounds, that means more than two things. So it's not just a metal and a non-metal. What it actually means is you have your polyatomic ions that are in the compound. A couple of things you need to notice about polyatomic ions. Look at their charges. All of them are negative except for ammonium. So ammonium is the only positive polyatomic ion. Now, if you haven't realized this yet, the first element you always list in a compound is the positive ion, the metal first. And then you list the non-metal. You list always the positive ion, then the negative ion before you put it together. So that means that all of these polyatomic ions, except for one, will be listed second. They'll always be the second element in the compound, and they act as one thing. So all of NO2, it has a -1 charge. It is called nitrite. All of NO3 has a -1 charge. It's called nitrate. And so it's a nitrogen, two oxygens that have an extra electron, and you call that nitrite. It acts like, again, collectively acts like a non-metal. It's got a negative charge. Ammonia is the only polyatomic ion that can be listed first. Also, some things, years past, this is going to be I know there's not a lot of bright spots to having to do all this stuff at home and kind of having math all the time when you're in class, but we've always had students, they had to memorize all of these. For any year we've taught chemistry because it is the language of chemistry and you need to know it. But we can't hold you responsible for knowing all of these this year. So that does make things, in this instance for sure, this makes chemistry much easier than in the past because you always have that as a resource to name these compounds. So hopefully you feel good about that. All right. Anyway, so let me show you real quick how to write formulas for compounds that are metals for the most part and polyatomic ions. So calcium nitrate. The other thing I want you to notice about the polyatomic ions, because sometimes you're confused and you don't know what I want you. If I go, okay, write the formula for calcium nitride or calcium nitrate, and some people are confused thinking those are the same thing. So you need to understand, and if you look at the endings of all of the polyatomics, they all end in ate or ite, not IDE. Because if it's just a metal and a non-metal, like if it's just calcium and nitrogen, that would be called calcium nitride, IDE. But if it's a polyatomic, it would end in ate or ite. There are two exceptions. You just have to remember these. Hydroxide is OH, and cyanide is CN. So those are two polyatomics that, and you don't have to worry about peroxide, so don't worry about that one. But those are two polyatomics that actually end in IDE. So they're the exception. So all the rest of them end in ate or ite. So when I say write the formula for calcium nitrate, based on the fact that it ends in ATE, you know I'm talking about calcium, first of all, the metal, and I'm talking about NO3, which again, you can look it up. That's what nitrate is. Now it says negative. Anytime it just says negative, it means -1. It'll say 2 minus, it could be -2, 2 minus the same thing. That's the charge there. So 3 minus is -3, 2 minus is -2. So if it just says negative, it means it has a charge of -1. So again, we have to cross the charges to put them together. There's the charge of calcium right there. Calcium is +2. So you cross the calcium's charge is 2. Nitrate's charge there is 1. Because again, it just says negative, and that means -1. And then you cross the charges. The only thing different you have to do when you cross the charges to write the formula for a ternary ionic compound, again, those that have polyatomics, is if you bring a number down larger than 1 below the polyatomic, you must put it in parentheses before the number. So that number is larger than 1. We're going to cross the charges like always. And if you're bringing a number down larger than 1 below a polyatomic, you must put it in parentheses, then the number. Because what it essentially means is it takes 2 of those nitrates to combine with calcium to, again, when you cross the charges, it ensures that the whole compound has no charge. That's because all we're keeping track of is electron movement. And what this really means there, if you're looking at a molecular level, it's a calcium with a nitrate attached over there and a nitrate attached over there. Each one of those has a -1 charge. The calcium donates an electron to each one of them so that they'll have that extra electron. And so the whole charge of that compound, again, is 0. And so that's why that's why we cross the charges every time. It ensures that we put the compound together correctly. And anyways, so there's calcium nitrate. Move on to the next one. You got that. And again, you can put, since ammonium is the only positive polyatomic ion, it can act like a metal. And so you can put it with any other polyatomic ion. And ammonium would be listed first. So, you know, this is NH4, has a +1 charge. Again, we'll just put 1 there. Or just a 1 charge. It's not -1 for sure. And then with sulfite, and it's got a 2 charge. Rules are always the same. We cross the charges, and the only thing different now is if you bring a number down larger than 1 below a polyatomic, you got to put it in parentheses. That number is not larger than 1. Don't change that. That's sulfite. Don't change it. Now, this number is larger than 1. You got to put it below NH4. You got to put it in parentheses first in the number. So NH4 parentheses 2 SO3. That compound would be again called ammonium because that's what NH4 is, and sulfite. That's what SO3 is. That'd be the name of that compound. Calcium and phosphate. Again, so calcium's charge is 2. It's in column 2 on the periodic table. Phosphate, look it up there. It is PO4. It says 3-. That means it's got a -3 charge. We've got to cross the charges to put them together. We always do that in an ionic compound. Bring that 3 over here. That's not a polyatomic ion, so we don't have to put it in parentheses. We just bring 3 down. But again, remember what I said. If you bring a number down larger than 1 below a polyatomic, put it in parentheses in the number. So you got to put it in parentheses like that. Ca3, PO4, parentheses 2. Aluminum and nitrate. So aluminum is 3, nitrate is 1. Again, we got to cross the charges. We got to put the polyatomic in parentheses before we bring a number down below that. Potassium and chromate. There's K. Look up and find chromate. Again, the ATE ending is telling you to look up a polyatomic. There's chromate. It is CrO4 2-. The charge of potassium is 1 because it's in column 1. Cross the charges to put them together. We don't put potassium in parentheses because it's not a polyatomic ion. We just bring the number down. And that number is not larger than 1. So when we don't bring a number down larger than 1 below a polyatomic ion, we don't change it. We just leave it alone. And so that is K2CrO4. Lithium sulfate. Charge of lithium is 1. It's in column 1. Sulfate, you look it up. We're not talking sulfur because it ends in ATE. That's how you know to not just look up lithium and S. So lithium sulfate is SO4 2-. Got to cross the charges like always. Li2SO4. Again, we didn't put that in parentheses because the rule is, again, when you bring a number down larger than 1 below the polyatomic ion, that's the polyatomic ion. You got to put it in parentheses before you put the number. That number is not larger than 1, so having 1 sulfate, we don't need to put it in parentheses and put 1. That's the same thing as just writing SO4. Ammonium dichromate. Remember, ammonium is the only positive polyatomic ion. It can be listed first. It acts like a metal. Dichromate, Cr2O7. Look it up. There's dichromate. Its charge is 2. Don't need to put that in parentheses, but we're bringing a number down larger than 1 below NH4. So NH4 parentheses 2, Cr2O7. And there's that compound. Magnesium hydroxide, Mg. Hydroxide is one of the 2 polyatomics that actually ends in IDE. So there it is, OH. Charge of magnesium is 2. It's in column 2 on the periodic table. Charge of hydroxide, it says negative. That just means -1. Got to cross the charges to put them together. But remember what the rule is. This is a very common mistake that people make on magnesium hydroxide. If you bring a number down larger than 1, is that number larger than 1? Yes, it is. Okay, and if that's a polyatomic ion, it is a group of atoms with a charge, then you got to put it in parentheses before you put the number. Ones are understood in the formation. You don't have to do that. Do the rest of those on your own. The answers are at the back. And again, you can pause this to do that and then come back and get the rest of it later. So writing formulas for ternary ionic compounds with transition metals. Again, remember, if they have a transition metal first, those in the center of the table, they're going to have a Roman numeral in the name to indicate their charge. And so that's what that Roman numeral means. When you see that, it means that's the charge of that element. Because when you look up chromium, which is right here, you have no way of knowing its charge. That's why they're telling you. And so you can still cross the charges to put that together. So chromium nitrate. So again, the charge of chromium is 3, Cr is 3, nitrite is NO2. You can look it up right there. Again, the ITEN is telling you that it is a polyatomic ion, and its charge is just negative. That means -1. Cross the charges, we're bringing a number down larger than 1 below NO2. So you got to put it in parentheses before you put the number. Cr, NO2, parentheses 3. All right, mercury 2 sulfate. Mercury is Hg, that's its symbol. Its charge is 2. Sulfate is SO4 and 2. There it is right there. Remember, before you cross the charges, you always have to determine, can you simplify them? If you can simplify them before you cross them, you do that. Those numbers simplify. 1 and 1, you end up with HgSO4. Lead 2 nitrate. Again, lead is Pb, charges +2. Nitrate, again, is a polyatomic. It is NO3, 1. There's nitrate. Cross the charges. Again, we're bringing a number down larger than 1 below a polyatomic ion. Got to put it in parentheses. We're doing that every single time. Crossing the charges to write formulas. 10 is Sn. That is the symbol. It is 4. That's what that means. Oxygen's charge is 2. Now, hold on a second there. You've got SN4O2. Remember, if you can simplify the charges before you cross them, you do that. We can simplify 4 and 2 to 2 and 1, then you cross them. SNO2. Do the rest of those on your own. Again, I would pause at this point, work those problems, and check your answers at the back, see if you got the right answers there. Naming ternary ionic compounds, again, with group A metals. Now, these are actually some of the easiest ones to name, in my opinion, because these are all, again, they're ternary because they're more than 2 things. But when that's the case, you typically have a metal and a polyatomic. Metal, polyatomic, metal, polyatomic. And all you have to do, and you don't even have to change the name. Like when it was calcium and nitrogen, you call that calcium nitride. But when it's a metal that you know the charge of, with a polyatomic ion, you simply name each one of them. You don't change the name of the polyatomic. So that is calcium, that is the metal, and C2O4, you got to look it up, and that's great. This does not have this one on there. I don't see it, but you need to know that one. C2O4 is oxalate, so make sure and add that to your notes. So that is calcium oxalate. That's what C2O4 is. So add it to your list of polyatomics that you need to know. And this one is potassium. Again, we know the charge of potassium. It is in column 1 on the periodic table. And MnO4 is permanganate. Aren't you glad you don't have to memorize these this year? That should make you happy. All right, Li2SO3. Li, again, is lithium. SO3, sulfite. Again, you can just look it up. There you go, lithium sulfite. Aluminum hydroxide there. Al is aluminum. Hydroxide is, again, one of the 2 polyatomics that ends in IDE. Do the rest of those on your own. Last thing here is naming ternary ionic compounds with transition metals. And these to me are the kind of the hardest ones to do, because you have to, again, to uncross the charges, because here's the thing, I should say, copper, again, like I say, when you name compounds, you have to consider where the first element is when you name it. And there's copper, and so copper needs a Roman numeral in the name, because every time you have a compound with a transition metal in it that you don't know the charge, you have to indicate the charge with the Roman numeral, which means you have to uncross the charges. Very common mistake people make there is they want to say that's copper Roman numeral 3. But that 3, with that polyatomic ion, that's just what NO3 is. That's what nitrate is. And so the 3 didn't come from copper. If a number actually came from the transition metal, it would be outside some parentheses. And basically, when you see no number below the transition metal, and this is not in parentheses, that means they did not cross any charges. The only reason you wouldn't do that is if they were both 1. You just write it as is, or if they're both exactly the same, because if you can simplify them, you simplify them before you change them. So if they were both 2 or if they were both 3, so you still have to do this. You have to check to see if the whole thing has been simplified. How do you do that? check the charge of the of the polyatomic ion. NO3's charge is 1. That means they didn't bring that number down. They didn't have to. That means the charge of copper was 1 as well. They didn't bring it down because, again, there's no parentheses around the polyatomic. So that's copper, Roman numeral 1, nitrate. HgSO4. Again, they didn't bring any numbers down. How do you know that? Or how do I know that? This would be in parentheses if they brought a number larger than 1 here. And if they brought a number from sulfate, it would be right below the Hg. So there, it's either mercury 1 or mercury has the exact same charge as sulfate because they've simplified it. So you look up the charge of sulfate. Sulfate's charge is 2. They didn't bring that number down. They simplified it. So that means mercury's charge was 2 as well. So that would be mercury, Roman numeral 2, sulfate. And keep in mind, these are the toughest ones. I've always seen more people struggle with these than anything else. The next one, iron. Again, iron is a transition metal, so it's got to have a Roman numeral in the name. ClO3 is chlorate. Its charge is 1. So again, we always check the charge of the polyatomic. And look, they've got a 3 there. That 3 came from the charge of iron. They've crossed the charges to put that together. Ones were understood. So that is iron, Roman numeral 3, chlorate. Next one. Again, it's lead. We don't know the charge of lead. You got to look it up to see that. Lead, and it's not always 4. It's in column 4, but it's not always 4. These over here can have more than one charge. So you look up what C2H3O2 is, and there it is. It's acetate. And so you can look up its charge. Its charge is 1. They didn't bring the 1 down. That means they have not simplified this compound, but they have a 2 outside the parentheses. That 2 had to come from the charge of lead. So that is lead, Roman numeral 2, acetate. Again, I would pause this, do the rest of these on your own, check your work later. And that is it for this lesson. Good luck.